Okay, I think we are online already. We are live. So, hello everyone. Nice to meet you again. And today we'll have a guest from Austria, Andreas Grabner, because it's his name. He's in this industry for quite a long of time. He has experience as a developer, tester, architect, and probably many other functions. And you may already know him because we had the honor to host him a couple of years ago on Krakow Meetup, even twice, if I remember well.
Exactly.
And yeah, I'm very excited because today he's going to show us a little bit how site reliability engineering work looks like, and tell us about a Keptn. I don't know if I spell it well, tool, which he is contributing to. So nice to see you again, Andreas. How are you?
I'm good. And as you said, I think I was lucky to be in Krakow twice. And I would wish soon, obviously, that we are all back, because it's better to do these things in person than just doing it remote. But it is what it is, right? That's the situation we have to deal with. And it's great that you are offering these remote sessions and also streaming it live to YouTube. That's great. Yeah, but overall, I'm good. As you can see here, my kitchen. And I know you said earlier, is this a virtual background or is this for real? It is for real. It's really, I can interact with my virtual background. These are all real plants. And yeah, all good. Thank you.
Yeah. On real meetup, we can take a beer after the presentation, but today it will be difficult, but everyone can take a beer on himself. So are you ready, Andreas? We can start?
I'm ready, yeah.
Okay, so let's start.
Let me share my screen then. All right, so let's see, here we go. Yeah, as I said, thank you so much for having me. I have been giving a couple of talks over the last couple of months around promoting our open source project Keptn. I actually believe the last time when I was in Krakow, I think it was a year and a half ago, I didn't talk about Keptn, but I talked about a predecessor of Keptn, a capability that we built back then, which we called Pitometer, to automate test analysis. And this really evolved into what we now have as Keptn. Now, Keptn, you will learn what Keptn is later today, how you can use it, what it's good for. My focus today, though, really is, as you said, Martin, talking about automating SLO-based performance testing. I will explain what SLIs and SLOs are, where it comes from. It comes from site reliability engineering, and how Keptn can not only automate performance testing, but especially, and I think this is the most critical part, is also the performance test analysis. Now, if you want to know more about me, you see all the information. You can find me on LinkedIn, on Twitter, also on the bottom, the Keptn project. If you want to follow us, if you want to star us, if you want to join our Slack, please do so. We are a CNCF project, a CNCF sandbox project. So CNCF is the Cloud Native Computing Foundation. If you have any questions, I know Martin is there. He will moderate a little bit live. I will also try later on, obviously, to watch the YouTube channel if there's anything coming in. But otherwise, also feel free to hook me up on all of these channels. So let's get started. My demo today, and actually I want to kick it off with a demo. But before I kick it off, let me just explain one of the things that I want to achieve. I want to be able to say, hey, Keptn, I have an app that runs somewhere, right? It's accessible through some URL, internal, external URL, and it is monitored by your preferenced monitoring tool. In my case, it's going to be Dynatrace, because at day I work for Dynatrace, and otherwise I'm doing a lot of work with Keptn, but I will be using Dynatrace, but you can also do it with Prometheus or any other APM tool. I believe for testers, for performance engineers especially, we need to look into APM, into monitoring, and into observability. So what I want to say, hey, Keptn, here is my app. It is monitored by some tool. Like in my case, it's going to be an app that is not all that pretty, but it's my sample app that I'm using. It's a Node.js-based app that I've deployed on a Kubernetes cluster. And I'm monitoring it with both Dynatrace and Prometheus. Now, what I else want to say, I want to say, hey, Keptn, please execute my performance workload using my tool of choice. Again, Keptn, as you will see later on, can integrate and trigger any type of testing tool, whether it's JMeter, Neoload, Gatling, Locust, Load Runner, whatever it is. It can trigger all these tools. I will be using JMeter today. And that means Keptn, once I ask Keptn, please execute the test, it will launch that tool, it will execute the test. And then the most important thing is once the test is complete, once done, Keptn, please analyze my SLOs, my service level objective score, based on my SLIs, based on my indicators, my metrics that you can retrieve either from the testing tool like JMeter or from Dynatrace, Prometheus, and so on, and then give me back a result that is easy for me to understand so that I don't have to go into all these different reports and dashboards. So essentially, in a nutshell, this is my end goal for today. I want to show you how you as performance engineers, as quality engineers, can use Keptn to automate your test execution and also your test evaluation, the result evaluation. And before I go on with the slides and explain a little bit more about what Keptn is, let me actually go into my environment. I just want to quickly show you what I've installed. So Keptn itself, I've installed Keptn on a Kubernetes cluster. That means Keptn itself is a container-based architecture, and you need to install it on any type of Kubernetes flavor. I have chosen here EKS. We also have installation scripts where you just need a Linux machine because there's some very lightweight Kubernetes distributions like Micro Kubernetes, Minikube, or K3s, which is one of my favorites. So really, if you're not experienced with Kubernetes, don't worry. We have a single line installer for you where the only thing you need is a Linux machine with 2 GB of RAM and 4 GB of disk space, and then we install everything for you using K3s. But as you can see here, in my case, in case you're familiar with Kubernetes, I've done it earlier, but once you've installed Keptn, you install it in the Keptn namespace by default or typically, and you can see there's a couple of components. The important things for me today is the JMeter service. So in order for Keptn to talk to other tools, you are integrating or connecting your external tools to Keptn through a so-called service. And I will explain to you later on how you can write your own services, how you can extend Keptn and integrate your services. I also have the Dynatrace service and the Dynatrace SLI service here because I'm using Dynatrace as my primary monitoring tool. What else is interesting? I have a notification service. I also have my Slack integration turned on. So every time Keptn does something or Keptn is finished with a task, I can also get a Slack notification. The data itself, Keptn is storing it in a Mongo. It also comes with the installation. What else is interesting here? You can do some other things. Like one thing that I will also show you is that Keptn can not only test and evaluate, it can also deploy a service for you. So if you're going towards, for instance, Kubernetes and microservice and container deployments, you can actually say, Keptn, please, before you run the tests, deploy the latest version in the cluster, then run the tests. And for this, we can, for instance, use the Helm service. And there's some other things. Important for you are maybe one or two others. The bridge, this is the UI that we'll see in a second, and very important, also an API. Because we can control and trigger Keptn also through an API. And I will show this later on with Jenkins. I'm going to trigger the whole Keptn workflow through Jenkins. But this is what I've installed. Let me go now to my browser, and I need to just look at which browser I am. Where's my right browser? I have a couple of browsers open. This is the bridge. So remember, I have Keptn installed. Now, if I install Keptn, then you get we call it the bridge. That's the UI. Keptn is organized in projects. I have a couple of projects here that are used for different use cases. I, for instance, have one project where I do multi-stage delivery. So in this case, I have a project where I can have Keptn move an artifact, a container, for instance, into dev, into staging, and into production, always run some tests and evaluate. Now, the primary project that I'm focusing on today is what I call performance as a service, because remember, my talk today is really about running performance tests. Let me just sure why this doesn't close. I want Keptn to run performance tests for me. So I have a project called Perf as a service project, and I can onboard multiple apps here. And the one that I'm going to use, just zoom out a little bit, it's a little bit too big. It's called Perf as a service. This is where I have a single stage that is called performance. And I want Keptn to run a performance test against a particular application, against a particular URL, anytime I want. And then I also want Keptn to execute a particular workload for me. So as you can see here today at 15:27, I ran a test. Now I want to do the same thing, which is, what time is it now? It's 6:11. So I want to ask Keptn, please run a test against an app. Now, first of all, drum roll, not that exciting, but this is my app. Okay, so this is my app that I've deployed on this particular URL. This app is monitored by Dynatrace. So this is my monitoring tool where I have automated monitoring turned on. So I built a dashboard of metrics that I would normally look at. And what I want to do now is I want to automate the whole thing. And I want to say, remember, Keptn, I have an app on a particular URL, and I want you to execute my tests. And then I want you to give me the results. So this is what I'm doing now. I say build with parameters. So this is just a Jenkins pipeline where maybe your Jenkins or whatever you have, if you have GitLab or if you have Harness or any other tool or Circle CI, I don't care. It works with any pipeline. Basically, this Jenkins pipeline here, what it does, it makes a call to Keptn and say, please, Keptn, do a particular thing, like automate the performance testing. So remember, I've told you that Keptn is organized in projects, stages, and services. So here I'm saying, Keptn, for this particular project that you have, for the performance stage, for the performance as a service application, I want you to use Dynatrace monitoring data later on. I want you to execute a certain workload, and I will show you what this workload means later on, right? I'm selecting performance now, but I have performance 10, 50, 100, and long. These are just logical names for workloads. I can also specify what type of SLIs I want to use, like which list of metrics. Then the URL, right? I'm pasting it in to make sure this is really the one. Remember, this is the URL of my sample app. Perfect. And that's it. And then wait for result is if I kick it off. Remember, Keptn is doing something asynchronously. Keptn is also an event-driven system. I'm sending Keptn an event, and then Keptn is doing its thing. And then I can constantly either poll for the status. I can also have a callback. In my case, I'm running a Jenkins pipeline. There's no real callback to Jenkins. So I just let my Jenkins pipeline wait a maximum of 60 minutes. And in that, it's always polling once it's done every couple of seconds. So if I click build now, then what just happened is my Jenkins has told Keptn, please execute a test against that URL with this particular workload. Which means if I go back to my Keptn's bridge, I should see on the left side here, see that today, 18:14, that's now. I just see that there's a new request that just came in. The request comes in through our Jenkins integration, and the actual event that was sent to Keptn was asking Keptn, please do a performance test. Remember, this was the drop-down box with the different workloads. Please do a performance test. And by the way, here's more information about the caller. We have the concept of labels. So I can see this was triggered by build number 55. Because remember, if I go back to Jenkins, if you are familiar with Jenkins, this is build number 55. So I pass this over as a label. I actually have it twice here. The job name and also the job URL. So this actually links back, if I open this one up, to the Jenkins pipeline. Right? Everything is fully linked. That's nice. And now Keptn will do its job. It will execute tests. It will then do the evaluation, and then it will come back to me with a result. Now, one additional thing I want to show you before I go back to the slides and explain a little bit more about the logistics and the architecture is you may wonder the test strategy performance. If I go back to my Visual Studio Code here, The only configuration that I have to give Keptn in order to work is obviously my testing scripts. So Keptn internally holds a configuration repository, a Git repo. So when you set up that initial project, you need to upload. In my case, I uploaded load.jmx. This is my script. And then you can also upload for JMeter at least a so-called jmeter.conf.yaml. This is where I can specify different workloads. So when I ask Keptn, please execute, remember the performance, where's performance? Here we go. Please execute test strategy performance. What Keptn will actually do, it will launch this particular JMeter script, and it will then pass particular parameters, properties, or variables to JMeter, like in my case, 10 virtual users, running them with a loop count of 100, with a particular think time, and also a particular accepted error rate. The nice thing is you just specify your different workloads. Obviously, you can specify different scripts here. You can upload multiple scripts and also your data files to that directory on Git, so that your script can really do data-driven, like a real load test. Now, Keptn doesn't write the tests for you. You obviously have to bring your tests, but you basically say, what type of workload do you want to run? And this is what Keptn is now actually doing and running for me. And actually, look at this. I talked long enough, which is great. Keptn is an event-driven system. That means initially it started with my Jenkins sending an event to Keptn, saying, hey, I have a deployment for you. This is why this is actually called the deployment finished event. And then Keptn knows once a new deployment is done, the first thing is it needs to execute the tests. Tests are now finished. So in this case, the JMeter service said, it took about 2 minutes. Everything is good. Next thing is Keptn starts with the next phase, which is retrieving performance data, or we call them SLIs, service level indicators, from my monitoring tool. In this case, it's Dynatrace. It will retrieve the data for me from my monitoring tool, from my dashboard. And once everything has been retrieved, all the data has been retrieved, it will then give me an automated assessment of the quality. So let's see, I talked again long enough. You can see if I scroll down now, first Keptn said I need to retrieve data. Then my integration with Dynatrace reported back, hey, here is the data for you. And then Keptn is doing the evaluation for me. So what you see here is what we call the heat map, which is every single metric that I have specified, that I told Keptn to analyze, also through a config file, was retrieved. Every single metric or SLI was evaluated against what my expectations were, or objectives, we call them SLOs. And then we calculate a total score, which is the top here, which is a number between 0 and 100. And because everything is green, I assume I have achieved 100 points, which is pretty cool. Right? And that means Keptn is now done. And remember my Jenkins from earlier? My Jenkins pipeline is now also finished. It says everything is green. Everything is done because, Keptn was executing and we retrieved the result. You also have here some of the artifacts. The evaluation result here is also available as JSON. So you can have, I guess I didn't have the plugin installed, but you can get all of the results, or you also get the link back to the results bridge. So here's the link back, and that gets you directly to the performance as a service, and then you are also directly from Jenkins back to Keptn. All right, so now this was a lot of talk already and kind of demo. Hopefully that showed you. If I go back to my slides, what I did is I said, hey, Keptn, I have an app. Please run a particular test with a particular workload. Once it's done, you retrieve metrics, and then you calculate an overall score. That's what I want you to do. Now I want to give you a little insights and kind of look behind the scenes on what this really is, because Keptn is also more, and I want you to understand what else you can do and how it works. So for me, Keptn is actually different things depending on who I am. Because what Keptn really does, it allows you to pick a use case that you want to automate. One that is very important, and you saw this already, is what we call SLO-based quality gates. The other one is SRE automation. This is the whole thing you just saw. With SRE automation, we mean test execution, optionally or additionally chaos tool execution while the load test is running, and then evaluation. Then we have a use case that supports end-to-end delivery, and we have a use case for production where we can do auto remediation. So you pick a use case that you want Keptn to automate for you. Then for every use case, you need to bring your configuration. For instance, you need to bring the workload. You saw the jmeter.conf file earlier. That would be the workload definition. For the quality gates, the evaluation to work, you need to bring your SLIs and SLOs, and there's also other files for different use cases. Most important thing is you can connect your tools. Keptn itself doesn't do the test execution. It doesn't do the monitoring. It doesn't do the deployment. It orchestrates, right? You can connect your tool that does the deployment, the testing, the monitoring, and then Keptn is really orchestrating all of these tools so that you don't have to build your own integrations to do a thing like test execution, then evaluation. We have done this for you. So what Keptn does, it automates the configuration of your tools, putting them into the use case and workflow, make sure that the monitoring is connected correctly, and you can see all the rest here for yourself with a little screenshot of the UI that you've seen. Underneath the hood, what's very important is that all the configuration is declarative. That means you define everything either in YAML or JSON files. Everything is stored in Git. That means every time you want Keptn to do something, you first have to make sure that the Git repository that Keptn connects to has the right test files, the SLIs and the SLOs, the workloads. And typically you will put this next to your own source code or your other tests. And then as you trigger Keptn, you just give Keptn access to these files. Very important, SLOs, service level objectives. I come to this later. This is very core to Keptn. And on the bottom right, standards. Keptn itself is open source, and the way we communicate with other tools, like with JMeter, what you saw earlier, is through an open source standard. It's called Cloud Events. It's a JSON-based protocol, which makes it also very easy to connect new tools. And I think the most important thing is it's not a proprietary integration. We are allowing you to build integrations based on a standard. And we are also in the CDF, in the Continuous Delivery Foundation. We're in the CNCF, and we are also in the interoperability special interest group. We want to establish an open standard to connect all tools through a common protocol. All right. Quickly, a couple of stories of people so that you know what's possible with Keptn. Sumit from Intuit, he has been using Keptn in the combination with Argo, with Jenkins and Gatling for their, they call it large-scale distributed performance testing, and they're using Keptn just for the quality gates. That means they have already figured out how to trigger Gatling tests from Argo for all of the different microservices, but then Keptn is there at the end to do the quality gates based on SLO, like the calculation that you saw earlier of this score. Roman from Triscan, they are working with a lot of companies, especially in the financial industry, where they're using Jenkins and Azure DevOps and also Neoload as a testing tool. And they're now using Keptn to orchestrate all of that. That means they're using Keptn to trigger the execution of tests and then also do the analysis and providing it as a self-service back to their engineers as part of Azure DevOps pipelines. And with this increasing the number of test execution, number of test steps. And Christian from ERT, he's a senior DevOps engineer. They are using Keptn for a little more. They are using Keptn for delivery automation. They have GitLab, and then they use Keptn to do from GitLab the whole orchestration of their Catalan tests, their JMeter tests, also the deployment and the promotion. And with this, they are now automating the delivery, including full performance test automation in their pipelines. All right. Now, this is the architecture slide I want to quickly give you. You've seen me earlier show you my kubectl get pods. So you know that when you install Keptn, you install it on Kubernetes and you have a list of pods. But really what you get when you install Keptn, like the raw installation, you get what we call the control plane. So the control plane is the core component that takes care of all the logic of orchestrating processes and sending events to all these different tools. If you want to use Keptn, just as you saw me earlier, you have to create a so-called Keptn project. And in that project, you need to specify what should this project be for. Should it be for delivery? Then you have to specify a so-called shipyard file where you specify, do you have a single stage for performance testing? Do you want to have multiple stages? If you want to use Keptn also for deployment, what type of deployment should happen? A blue-green, a direct, a canary, you can do all that. So you specify that in the shipyard file declaratively. If you want to use Keptn for auto remediation in production, you can specify a so-called remediation YAML file where you can specify if Keptn is made aware of a problem in production, a system crash, something is slow, then Keptn can trigger the right tools to then fix the problem. So on the top, you have somebody that defines your processes and your projects. Now, the second thing is, and this is now the big separation of concerns in Keptn, there is no hard-coded integration of these projects with which tools are used. You have a separate team that takes care of installing tool extensions to Keptn. And in the tool extension, we call it a Keptn service, really listens to Keptn events, because internally Keptn is an event-driven system. So you can see here, Git for config, Helm or Jenkins for deploy, JMeter or Neotis for testing, Prometheus or Dynatrace for monitoring, or Keptn remediation or ServiceNow or whatever for remediation. So you have one team that defines the projects and processes, and then the other team that defines the tooling. And you can change the tooling without having to think where this tool is used right now in which processes. So that means you can switch from, let's say, JMeter to Neotis without having to figure out where's the impact. And you can also change your process. So you say, instead of doing just a performance test, we may want to first do a quick functional test and then the performance test. So you can change the process and don't have to think about the tooling. And the beneficiary is either the developer, the tester, whoever you are. And then you can say, hey, Keptn, I have a new artifact, and I want you now to basically execute that process, the delivery, just the testing, just the quality gate, or the remediation process. And what Keptn does, it sends events for every stage in the process, and every event is then picked up by the right tool that you have configured to consume that event, and then this tool is doing it. So this is a high-level overview of what Keptn is. If you want to get a more detailed description about the architecture, I've been doing a couple of meetups in the last couple of months, and in the software circus that I did on October 1st, I did one where I really went into more of the details of the architecture, why we built it that way, and also I showed more of the continuous delivery use case and the auto remediation use case. But today I really want to focus on the test analysis and providing performance testing as a self-service. Okay, but check these out. So first use case. I know you are all quality engineers out there, so analyzing and automating quality gates to automate the analysis, can be a trivial thing, but can also be a very tough thing depending on the test. What we have seen is that a lot of time is spent in manual verification, especially the more complex your tests become. So let me give you an example. I know a lot of you have invested in pipelines, in automation at least, right? Whether you use Jenkins or GitLab or anything else. And building and running unit tests, is easy. A unit test fails or succeeds. There's a clear definition of success or failure. The thing is, though, if you add more and more tests to your pipeline, whether it's end-to-end functional tests or performance tests, right? This talk today is about performance engineering, performance tests. You get more and more data. If you also add monitoring to the mix, whether it's Prometheus or Dynatrace or Datadog or New Relic or any other tool, you get more and more data, and it becomes more and more complex to really say, is this build now better than the previous build? It seems to be as fast as before, but we're using twice as much CPU, or the garbage collection runs much hotter, but we have more hardware now, so everything is faster. But what does this really mean? Is this good or is this bad? And we're making 50% more database calls than before. It's still fast in our test environment, but is this a good or a bad thing? So this is why I see and we see that this is very hard to automate the analysis here. However, we think we can analyze, we can automate that. We can definitely automate that. And essentially what we want to solve with Keptn is, instead of you having to build your dashboards, maybe one dashboard in one tool, maybe multiple dashboards in different tools if you're comparing performance test results with your monitoring data. But instead of manually looking at the same dashboards after every build, and then, yes, you're getting better the more often you look at it, but this is not efficient. Instead of having to look at these dashboards manually, what Keptn really does, it automates that process. It allows you to connect to these tools and pull in the raw data behind these dashboards, and then compares them based on the rules that you tell Keptn. All right? So the way this works is, again, not an invention from us. It's a very easy concept. We are applying what Google defines under their site reliability engineering practices, or at least one of the concepts. It's around SLIs and SLOs. So what is SLI and SLO? An SLI is service level indicator, is a metric, basically, something that you can measure, like the error rate of login requests. If you're testing an app, or if an app is in production, and you can measure somehow how many login requests fail, then this is an SLI, right? It's a fancy term for a metric. Then we have SLOs, service level objectives. This is where you say, what is the success criteria? What do you consider this particular SLI to be good? Could be login must be less, or login error rate must be less than 2% over a certain period of time. Or in the period of a test, you're not allowing more than 1%, right? So it's just a threshold, basically. Now, for those of you that have done any work in operations, in ops, then you also know the term SLAs. And you may wonder, well, SLO sounds very much like SLAs. It's similar. An SLO basically says, this is what I'm expecting. And an SLA is then typically what happens if we are not meeting our SLOs. So for instance, maybe there's a business contract, or maybe we just lose our users because we're delivering a bad service. Right? It basically says what happens if we are missing our SLOs. Now, I didn't come up with it. Google did a great job with talking about SLIs and SLOs. There's a great video that I at least found very good and very educational. So check this out on YouTube. Essentially on the top it says SLIs drive SLOs, which then inform SLAs. Now, why am I talking about this? Because we don't want to reinvent the wheel. Because what we have seen when we work with people that are adopting Keptn, and remember, I also come from a Dynatrace background, so from a monitoring background, we see a lot of people now looking into SLOs and actually sitting down and defining their success criteria for the individual services for a particular time frame, whether it's a month, a week, a day, an hour. And typically your monitoring tools allow you to measure these SLIs and compare them against the SLOs, and then, for instance, alert on it or report on it. And that's already great if we have it in production. But what we are now saying, if this is a concept where we finally have people sit down and say, this is good, then why not shift it left? Shifting left means, why not just take it in our delivery process? Why don't we include the same SLIs and SLOs in performance testing? And if we integrate performance testing automated in CI/CD, why not do it after every commit? After every commit, we want to run some performance tests, even though they might be smaller in scope, and then evaluate the metrics against our thresholds. And that's the whole idea with the Keptn Quality Gate capability, that you can at any point in time ask Keptn, please look at these metrics, these SLIs, compare them against these SLOs, and then tell me how good all of these are. Right? How good are they? I mean, what is my score? Is it green? Is everything green? Is just one thing red? What is it? So to give you a little overview and explainer, because I think it's an important concept to understand. The way we use SLIs and SLOs is you define SLIs as metrics, as I told you. Right? You basically say, from your monitoring tool, I have these metrics, or from your testing tool, you have these metrics, or from a security tool. The nice thing is Keptn, and you will see this in the next slide, can talk with any type of data source. That means you can include monitoring, testing, security, code coverage, anything can be included as an SLI. So you define the SLI, you define then the SLO. So what are your objectives? Here in Keptn, we allow you two things. You can either specify a static threshold for pass and warning. So like the first one is an example where response time should be faster than 100 milliseconds, then it's green, or it should be at least faster than 250 milliseconds, then it's warning. So that's one option. The other thing what you can do, you can also do relative changes. For instance, with the last one, where it says test step login, number of service calls. Here, we basically say we are not allowing any change. Plus 0% means we're not allowing this metric to change at all. In the previous line by response time, we can also, you see the combination. You can say, hey, I want response time to be faster than 150 milliseconds, but I also don't want it to increase from one build to the next by more than 10%. So it's really flexible. And so this is what you specify on each individual SLI. And then overall, Keptn calculates a total score and then normalizes it between 0 and 100. So you can say, overall, I want to achieve 90% green, and then everything is good. So now how does this work? If you have your first build, you deploy it, you run a test, and then you say, Keptn, now you analyze. And then Keptn pulls in the metrics from your tool, from your tools, one or two, right? How many? Everything is green, that's 100%. Build number 2 comes along, you do it again, the evaluation. Again, you don't need to look at the dashboards anymore, Keptn is doing it. Then 2 are in yellow, which means it's only 75%. By default, every metric is weighted equally, but you can also say one metric has more weight and can achieve more points, was more important, by the way. Now build 3 comes along. It seems that the response time problem and the failure rate problem from build number 2 was now fixed, but all of a sudden we have more backend calls to the backend service. It increased from 1 to 2 calls, which is violating our SLO, which is why we're getting penalized, and we are only achieving 62.5%, which makes this build red. And because this is so automated and hopefully fully integrated in your automation, in build number 4, right, the developer fixes these things right away and then makes the pull, makes the build, and you run the test executions automated, and then you automatically get back to the state where you really want to be. This is kind of the explanation where you also see build-to-build comparison, how this works. Now, how does this work from an implementation perspective? Keptn is an event-driven system, as I told you earlier. That means Keptn can talk or can pull data through events from many data sources. In order for every data source to know what to pull, you have to specify first your SLIs, your service level indicators, and they are specified specific to the SLI provider. Here's an example for a Dynatrace SLI file where you specify error rate is this particular query, number of database calls, count DB calls is this query. For Prometheus, this would be a list of PromQLs. For Neoload, it would be a list of metrics from Neoload, and from whatever other tool you have, you would have your individual queries, but always a logical name to a query. Then the SLO that I just showed you, this is basically not specific for a tool that provides SLIs, but this is overall. This is where you specify for which SLI do you want to have which type of criteria, just as I showed you earlier in my Excel kind of table format. And then if you have specified this, and then you ask Keptn, please do the evaluation, what Keptn then does, it sends an event to all the tools that are registered with Keptn that can provide data and say, please give me your data. Here are your config files. Here are your SLI files. Then each tool can report back the metrics, the actual values. Then Keptn takes all these values, looks at everyone, and then compares it against pass and warning, and then gives points, and then overall calculates a total score. How many points have you achieved? And then normalizes it to 100%. Right? So what that basically means is that you can take this facility to really automate now the normally manual process of analyzing data. Remember earlier I said it's very hard to manually analyze these results, and it slows down your end-to-end delivery pipelines. But what I'm telling you, you can now use whatever in automation you already built in Jenkins or in Git or wherever, where you run your tests, and then instead of manually looking at dashboards and reports, you can use Keptn to query all of these results from your data sources, your monitoring tools, your testing tools. Let Keptn do the evaluation for you, and then let's report it back to your pipeline, just as I did earlier, right? So you can integrate this with any type of pipeline. And this is then obviously reducing the normally manual time to a fraction of seconds or milliseconds, because this is all automated. Yeah, I want to quickly go back to the demo to show you a little bit on how this works. And then I have the other sections, and then really hope that we have a couple of questions. So you may have wondered, where do all of these metrics come from? Now there's two explanations here. The one explanation is that I have shown you in my beginning, is that we allow you to upload, as I mentioned, these SLIs and SLOs, right? So one option is, and this is I would say the more GitOps option, you are allowing your performance engineers specify these are all the available SLIs, and then you add the query to it. So you specify, here are my metrics, and depending on the tool, then this is the query. And then you give this to Keptn. And with giving it to Keptn mean you upload it to the Git repo that Keptn uses for the specific Keptn project. So this is an SLI. You have all of these particular metrics. And then we also have the SLO. And here's the SLO, just as you saw in my slide, right? For every single metric, pass, warning criteria. You see here also the weight, so you can define different weights for every metric. So this would be, if this fails, or if this succeeds, it gets twice as many points as everything else, because the default weight is 1. So you can upload this. The other option that we found very useful, especially if you get started, is if you're using a monitoring tool that has some dashboards, where it's maybe you'll use Grafana. In my case, it's Dynatrace. We have built an integration with Keptn where I can build a Dynatrace dashboard like this. So I just put metrics on my dashboard that I would normally look at this dashboard. And then if I zoom in here a little bit, right, you can see here that this dashboard has been augmented with additional data. Like I can say, hey, this is the response time P95, that's the 95th percentile. And with the augmentation here, where I say SLI equals service response time P95, I tell Keptn that, hey, Keptn, don't look at the YAML files, but take this dashboard as basically your definition for your SLIs and your SLOs. So take these metrics and then also pass and warning, right? You can see here a couple of examples. Then Keptn is just parsing it, is then creating the SLI and SLO YAML underneath the hood, and is then asking the tool, in this case again Dynatrace, to give me the data. But I think this makes it very easy to get started until you get into a mode where you have figured out all of your SLIs, and then you just let your performance engineers or developers or architects just modify them in Git. But the cool thing is all the metrics here are then automatically analyzed. Right? As you saw earlier, this was my performance test, and let me just zoom out. Yeah, 100%. So every run here, let me run one more. Maybe we just run another performance test while I'm talking. Build with parameters. Now I'm running a different load test. Let's do the performance 50 build. And so this will now again trigger the next test. Now this, as you know, takes probably a minute or two. What we should, however, see soon is that new test coming in. So let's wait for this. Just that you see that I'm operating here on a live patient. So I think this screen refreshes every 30 seconds. And let's just see here. Let's refresh it. I'm inpatient today. There we go. Right. So this is now the one that I just kicked off from Jenkins. Now executing performance test strategy 50. Now this will take a couple of minutes. So let's go back to this one. right? This was the previous test. So here in the heat map, I see this was the latest test, build number 55. You also see it in the X chart, and then the previous one, the previous, and like the second to last, and so on. You may also wonder, when I click on this, why is this kind of gray? Because you can specify a comparison strategy. Do you want, when you have relative values, do you want it to be compared with the previous test, regardless on whether it was a good test or a bad test, or do you only want to include and compare yourself against the previous good one? This is why, if I select this one, I see the comparison test is this one here, and not this one, because this one actually didn't do good. I can also specify that Keptn should calculate a baseline across multiple tests. In my case, I've only specified just take the last build that passed. So I see the heat map. Down here, I also see each individual value. I also have a chart option, so I can look at these metrics, right, over time in the chart. Also, I can query this data through REST. So in case you wonder, there's like a little thing here that actually gives you the underlying protocol of the data that is sent back and forth between Keptn and the different tools, and you can also query this data. So if you don't like our visualization, or you want to use this data somewhere else, you can also extract it. Okay. So this is this, and then I guess, right, this test will run. Oh yeah, test finish. The performance test, the performance 50 was a short test, done, and now it's retrieving the latest data. Let's come back to this in a second, because I want to make sure I get through all of this, and then I also have time for questions. So this was now a core part, which is the analysis based on SLIs and SLOs. I've shown you how I trigger this from my Jenkins pipeline. I want to also bring in some of our users, right? Christian, they are using GitLab, where they're doing deploy, testing, and then in the verification stage, they basically make a call to Keptn and say, hey, Keptn, I just ran a test. Now you do the evaluation, and then you give me back the results. This is just an example of, you can integrate this in any type of existing delivery pipeline to simply automate the validation of your tests. Important for you now, I've shown you as an SLI provider Dynatrace. We also have Prometheus, we have Neotus, and we have Wavefront. If you have any other data sources or any other tools that you want Keptn to use also for the evaluation, then build your own Keptn SLI provider. It is very easy to do. I have a custom SLI provider that I've built for a recent conference. It is really, right, if you look at this, I just open up this. Sure, I trust my own content. Right. If you want to build your own extension, you just need to know, you can do it in any language. I prefer our templates that we've provided in Go. So this is my sample, Grabner Andy PEC SLI provider, because this was for a conference. And here I've also shown, there's also the slides for my talk online. This was just an example implementation where this provider is parsing a JSON result file, and it's delivering a certain data set from a certain section of the JSON, right? So everything is here, and the code is really, the only thing you need to do is you need to implement a couple of handlers. Actually, it's just this function here. If you start from the template, there's a function called handle internal get SLI event. And then this is the function that is then, and you see here, I've really tried to explain every single step. So that should be fairly easy. And if you don't like Go, you can do the same thing in any other language. All right, how did my build go? Test 56 is finished, as you can see here now. This one now is not that great, because it seems we have a service response time P90 and P95, so the 95th and the 90th percentile violating our SLAs. And therefore, we got penalized, and therefore we only achieved a total of 81 points, even though we said we want to have 90 points for good. Okay, so you can see this here. And if you want to see the details, we also have the link from here directly to the dashboard with the raw data. So now you can see also, what would the dashboard have looked like if I would have looked at the dashboard myself? But Keptn did it for me, so I don't need to look at the dashboards anymore after every build. Cool. All right. Now the next use case, right? And now I think we covered most of it, so this is just going to be repetition. What I've kicked off in the very beginning is a scenario where I have Keptn execute a test for me. Now let me tell you first why we built all of this, because we know it is possible, obviously, for all of you to build your own performance test automation. Now, it is possible, but there's a lot of questions, like where do we run the tests? How much hardware is needed? You can read for yourself. Where do we string the metrics to? There's also a lot of do-it-yourself approaches out there, a lot of great guides, so you can all do it if you want to. Feel free. However, we thought we wanted to also provide this capability, and then obviously combining it with the automated analysis, what I've just shown you. So instead of building this thing in your own Jenkins pipeline or whatever tool you have, you can just say, hey, I'm just using my pipeline for deploying a particular application, and then I'll just take Keptn to also execute the test for me. Just as what my two examples have done earlier, Keptn can execute the test, can then validate the SLOs, and then at the end bring back the result. Right? Oops. Right? Which means you don't have to deal with building this yourself. We've built this for you. And because of the event-driven nature and the way we can integrate any type of tool, you can then add whatever tool you want here to the mix, and then add any type of data source, and then always come with a very nice way of evaluating all of your results. I think I already shown this demo, right? If you want, the demo that I've shown now is also available on this GitHub repo. So github.com, Keptn-sandbox Jenkins tutorial. I have a couple of tutorials just for quality gates, for performance testing as a service. I also have one for full end-to-end delivery. So if you are interested in this, check out my tutorials and all the samples. An example also, again, from our real users, Christian, if you remember him, what he's doing, he is also taking these things that they built into their GitLab pipeline earlier, like the testing out, and they let Keptn do it. So now when they deploy, Keptn will run the test, will do the evaluation, and report back, which means their pipelines that they have to maintain in Git, they are much less complex because Keptn takes care of it. I think that's also something to remember. How can you build your own Keptn test execution service? Similar to the data service, the SLI service earlier, you can build your own service, right? It's very easy to build. We actually had somebody also from your team, from Krakow, giving a Keptn user group talk last week. And he was using Locust, I believe, and they're trying to build a Locust integration. Adrian. So it's really easy to build your own integrations, and with this, we make the Keptn community even stronger. Last use case before I open it up for question. While this may seem not related to performance testing, but I think it is. It's the future of performance testing. And I call this test-driven operations, by combining performance engineering and chaos engineering. So what that means is Keptn has one use case for production, which I believe is pretty cool. So if you install Keptn and you have it hooked up with your monitoring in production, and your monitoring tool detects a problem, like in this case, Dynatrace detects there's a conversion rate drop because of a CPU problem on one of their services, then what Keptn can do, it can execute your remediation workflows. That means somebody has to upload what we call a remediation workflow, and saying, if this problem happens, then do this action, and this action. And in this case, it seems Keptn has found this remediation file. Now remember, Keptn itself doesn't do anything, it just orchestrates. That means Keptn would look at that file and say, for the conversion rate problem, we have the first action defined as scaling up or scaling by incrementing it by 1. So Keptn will send an event, And then whichever tool you have connected to Keptn that can then handle this scaling up event can execute, will report back to Keptn when it's done, saying, I'm done. And then Keptn will evaluate, did this actually solve the problem? That means it goes back to your SLIs and your SLOs. We also call them BLOs, business level objectives, looks if the monitoring tool has closed the problem, and so on and so forth. If this is not the case, so if the first action didn't solve the problem, it would execute the next action. And then again, evaluate. So it's really we call it closed loop remediation. That means action, evaluate. And then again, action, evaluate. And in case nothing solves the problem, then the last action would be maybe to escalate it to a human being. And now, this is really exciting to think about it, that you're basically building self-healing operations or production systems. It's also very scary because this is also code that runs and logic that runs in production, and this should not go out there untested. Therefore, I think the next generation for performance engineers is actually to do, call it test-driven operations. I really like that word, but it's combining performance testing with chaos engineering, just as Adrian showed. And so the idea is you're running a performance test, and while you're running the tests, Keptn can also launch your your chaos tests. And then what you can do as performance engineers, you can first of all validate, does your monitoring and observability platform pick it up correctly? You get the alerts. And with that, you can then sit down with the architects and say, hey, if we are enforcing this particular chaos, like taking away CPU or killing the database or doing X, Y, Z, what would the right remediation action be that we can automate? So you can then, with that team, define remediation actions that Keptn executes as you're running the test while you're enforcing chaos. And with this, make sure that you have an auto remediation workflow in place that can bring the system back to a healthy state. You do this as long as necessary until at the end the system can withstand the chaos attack, because then and only then you really know all of your code under load and under chaos is really delivering services based on your SLOs. Okay? So it's the same thing what I showed you earlier, but taking it back into your performance environment and adding some chaos, and then really helping your engineers to also build an auto healing and self-remediation concept around it. All right, last piece of information, you can integrate Keptn with your existing CD tools. There's a lot of different integrations we have out there, but in general, there's a Keptn API. So let me quickly show you that. If I go back to my to the Keptn's bridge, then here on the top right, you can get the token. So let me copy the token, and then you can open up the Keptn API. It's a nice Swagger UI. So here you can authorize, and then basically the important ones are posting an event, or there's one particularly to evaluations, to a quality gate evaluation. So here I could say I want to evaluate the last 30 minutes for a particular project, right? I could say, what do we do here? Performance as I could basically just, say project perf is service, stage performance, and then service name is, what did I call it? Also, this perf is project, and this is perf is service. I was really good with names, I guess. Perf is project. And then I would hit execute, and then Keptn would trigger the evaluation. Now this one doesn't make a whole lot of sense because I don't have load on it. But actually, let's just do it. Just want to make sure that your perf is project, perf is service, and performance. Execute. It's been triggered. When you trigger an event like this as a response, Keptn is event-driven, which means for everything you kick off, for every workflow gets a unique ID. We call it the Keptn context. And with this Keptn context, you can then also do pull requests, or you can say, hey, is the process ready? Yes or no? So you can go in here and you can get particular events of a particular context, right? You can say, hey, is it done yet or not? But if I go over here, you can see there was a new event coming in. Let me just refresh here. That was the evaluation started. It's already done, right? Evaluation started. It was manual. That was me, and it just did a quick evaluation for the time frame of 30 minutes. Right? Obviously, in the last 30 minutes, I had some data, so I just kicked this off. And now, if I wanted to, you see here, additional property 1, additional property 2. You could also see some examples here on if I go back to my API service and I go back down here and I do try out, right? So this is also where you can add any type of metadata, these labels. So if you call it from an external tool, add links back to your tool, add any metadata, because that metadata goes through the whole process. That means any tool that Keptn involves in the process will have access to all of these labels. So you can see some tools then add more metadata. So that's really cool too. Good. I believe let's wrap it up, and then hopefully we have some questions. So hopefully you know, first of all, what Keptn is. Keptn, for me, is a really cool way of automating processes around delivery. And with delivery, I mean, it can be the smallest, just like doing quality gate evaluation. It can also be test execution and quality gate evaluation. It can also be delivery. It can also be auto remediation for production. So you pick your use case, and then Keptn connects all your tools and provides to you that type of automation, and then you can trigger it from anywhere where it makes sense. So have a look at this. And if you want to get started, there's great ways to get started with some tutorials, keptn.sh. And if you go to the Keptn website, which will get a complete rework, I think we are publishing it this weekend. So you should definitely check it out. And yeah, start from there and contribute and let us know. Join the Slack channel. That's very important. My last thing before, join the Slack channel on slack.keptn.sh. Star us on Git, follow us, let us know if this is something that helps you or what is missing. Yeah, and hopefully it makes your life easier. With this, let's see if we have some questions. Marcin, hopefully you are still there with me.
Yes, I'm still there. And yes, we are waiting for questions. So if you have any, please ask them on chat right now. Yes, this was really nice presentation, and I especially like the last use case with chaos engineering and this self-healing process. It really looks great, and I think it is worth trying.
Exactly, and you should actually, right? You have in our last user group meeting, and let me just see, because I'm pretty sure you know him. Oops, that was a wrong click. Where is Adrian?
I think I'm already. First of all,
here we go. Adrian has been doing a session on continuously evaluating application resiliency with Litmus, Chaos, Locust, and Keptn. I think that's something that is really cool. Yeah.
Okay, can you share the link on?
Yeah.
On this?
Yeah, definitely. Let me put this into the. Where should I put it? I put it into our chat here that I have with you, and then you can post it.
Yeah, definitely.
Yeah.
I have one question. I see that there is a question already, but I will ask my question first.
Yeah.
And I'm wondering because yeah, exactly. You show the homepage of Keptn of the project, and I'm wondering if, because I've seen a little bit a little small icon of Slack in integrations, and I'm wondering if it's possible to be informed in real time what happened in this pipeline. Like may I see that something happened without opening the website?
Yeah. So here is just a very basic integration that I have enabled for Slack. So you can see here, I get notifications every time Keptn does something, makes a configuration change, test finished. So I get these notifications. So Keptn is an event-driven system. That means every time Keptn does something and pushes, let's say, a process into the next stage, then one or multiple tools or integrations of Keptn can consume that event. And the Slack integration, that's actually done through the notification service. Let me show you that as well. So Keptn notification service. Here we go. So this service here allows you to integrate it either with Teams, Slack, and WebEx Teams. That's the integration that we have right now. If you have any other tools that you want to integrate with, we also have what we call the Keptn generic executor service. This one, if you enable this, it allows you to upload, I think I have some usage. It allows you to upload shell scripts, Python scripts, or webhooks. That means you can say, hey, Keptn, every time you have a configuration change event, or every time you have a test finished event, or for any event, please execute this particular script. And the script could either be a bash file that is executed within the container where your service runs. It can be the Python, or it can be a webhook. Right.
Okay, great. So here is the connected question, because the question is, what's the plan for the future integrations for Keptn?
So first of all, Keptn is an open source project. That means, right, we hope that the community will come to us and say, this is what's missing. And then either put in requests into our Git repositories, and then maybe some of them are actually implementing some of them, or we see such a big demand and then we find time. But what we see is integrations, as I said earlier, with low-cost. I think Adrian is working on that. I want to see a Gatling integration from a testing perspective. From a monitoring perspective, we hope that other APM vendors like Datadog and New Relic will see integrations. We've also talked with folks from Spinnaker, Keptn, Flux, that we get integrations there, so that Keptn, if Keptn, for instance, orchestrates the whole end-to-end delivery process, can make a call to Spinnaker for the deployment, and then Keptn can go on with the performance testing, right? Another option would be integrations. I think we already have MS Teams here, but with auto remediation tools. So one of the use cases that we have, remember, is the whole auto remediation, like fixing things. So we already have integrations with ServiceNow and with Ansible, but I'm pretty sure there's others like Chef, Puppet. This is what we want. And I think if you go to the way Keptn is organized, the core project is on Keptn. So this is where Keptn core can be found, and this is also where I believe we have them here. If, for instance, look for Spinnaker. Exactly. So we have under integrations. I think that might be the better way to look at this. Integrations. Right, and then remove Spinnaker. Right, so here are some of those. GitHub Actions, Relay. These are some that people have already put in. And if there's more others that people want, then let us know.
Okay, great, nice. You already showed us the tutorials page, but the question, what's your recommendation to start with? What should be the first step to learn to work with?
So honestly, when I started with Keptn, the biggest challenge I had understanding Kubernetes and because Keptn requires Kubernetes, right? And that was like 2 years ago. For me, Kubernetes was new, and I really struggled. And there might still be people out there where Kubernetes is still like, I don't like it and I don't know, it's too complex. So for people that are not familiar with Kubernetes, I suggest two things. There is one tutorial that's called Keptn in a box. And Keptn in a box is installing Keptn on a Linux machine using micro K8s, but it's just, you just execute a shell script and then it installs everything for you. It installs Keptn, it installs Git actually, it installs a sample app, it does a lot of things. That's called Keptn in a box. It's a great way to get started. Another thing, and that's one of my tutorials, is called Keptn on K3s. As I said, I think in the beginning, I really like K3s keys from Rancher. So this is kind of my tutorial on installing Keptn on a very small machine. So the only thing you need to do is, this is for Dynatrace, but other examples, you just need to run this curl command, and that's it. You can say, for instance, with Prometheus, and then it will just install on your local Linux machine Keptn on a K3s cluster, and it really, literally, I think there's some hardware requirements up here. 1 vCPU, 4 GB of memory. That's all you need. So the easiest is just to stand up some environment, and then you can do this. And then you don't have to deal with the complexity of Kubernetes. Now, if you have Kubernetes and if you're familiar with it, then I suggest there's a couple of tutorials out there on, installing Keptn on EKS, on AKS, or just the easiest is if you go to keptn.sh and go to the docs. Release 7.3 is current. 0.8 is coming soon. But if you're clicking on operating Keptn, then it just goes through the quick start. So you are just downloading the Keptn CLI, and then you install Keptn with Keptn install. And if you don't like that, because what Keptn install does, it will basically just install it on your kube config. We have some advanced installation options where we give you Helm charts. So then here we have all the Helm options and then just the Helm charts. Okay, hopefully this answers the question.
Okay, great. I think that current version is 0.7. So my question is because still there is no major version, right? The first version. So this tool stable already, or do you experience some stability issues still?
I don't want to lie, right? We are not bug free. We have also a major change coming up with 0.8, which is already an alpha version and which will be, I think, GA is planned for mid of February. That will change some of the events. But what 0.8 also has is two things. First of all, from a stability perspective, we learned a lot about performance of Keptn. We're using Mongo internally, and we ran into some performance issues with the way we were using Mongo because we didn't optimize on indices and all that stuff. So 0.8 has all of these performance improvements. But what 0.8 also has, we are ripping apart, and I think there's also on the YouTube channel from Keptn a really great set of videos, Keptn 08 Alpha explained, some examples. We are ripping apart the control plane from the execution plane. What that means right now with 0.7.3, I install Keptn on a Kubernetes cluster and everything Keptn triggers, like in this case, JMeter, the JMeter service and the load will be executed from within that same Kubernetes cluster, right? And this might be good, but maybe you want JMeter to be executed from somewhere else. And what we are doing with 0.8, we allow you to install the Keptn control plane, which controls the events and the processes. And we allow you to install the different services anywhere. So that means that allows you to use Keptn for executing tests somewhere outside of that Kubernetes cluster. You can also then use Keptn to do the deployment in other Kubernetes clusters or in other environments that might not be Kubernetes. So that's then all possible. So 0.8 is a big change, and we hope this is going to be the last time we also make major changes to the events itself, because remember the events, it's these events here, right? The ones that we're sending in. All of these events have a particular type, and the type exactly specifies what you want to do and kind of where Keptn should start with the process. And we are introducing a couple of new events to allow some new things that we couldn't do before, like parallel execution of actions and then waiting together until all the actions are done. So there's going to be start and stop events. That's important. Now, our goal obviously is later this year, hopefully, to get to a 1.0 release. That's our goal. The other goal for us is that we want to become an incubator project. So right now we're a sandbox project on CNCF, and we want to become an incubator project. And for that, we also need to get closer to that stage of 01.
Okay, great. I can't see any questions on chat, so I think we can slowly come to the end. And yeah, so we encourage every one of you to try this tool because it looks really promising. And thank you very much, Andreas, for being here today with us and showing us this tool. That was a pleasure to host you.
Yeah, thank you. And as you said, normally we would now take a beer and drink it together. We can just all take our beers now and in the spirit drink it together. And hopefully once the pandemic is over, we will all meet each other again. That would be great.
Yeah, next time we will definitely drink some beer together. Okay, so thank you very much. Thank you, everyone, and see you next time. Bye.
Thank you. Bye.